Alzheimer's disease. For millions of people, it's a truly devastating diagnosis. But what is really going on inside the brain? For well over a century now, scientists have been following the clues, trying to solve what is, without a doubt, one of modern medicine's greatest enigmas.
To really get a sense of the scale of this mystery, just look at this number. Back in 2019, nearly 60 million people around the world were living with dementia. And Alzheimer's? It's the culprit in the huge majority of those cases. We're talking up to 80%. So you see, this isn't just some abstract puzzle for scientists. It's a full-blown global health crisis.
So, at its very core, Alzheimer's is defined by two telltale signs, two major clues that are found in the brain. First, you have these sticky clumps called amyloid plaques that form between the brain cells. And second, you've got these twisted fibers called neurofibrillary tangles that build up inside them. These two are the main culprits at the center of our whole investigation.
Okay, so our investigation is going to start by going deep inside the brain to really examine the evidence, the clues, that this disease leaves behind.
And you know, this isn't some new investigation. Ever since Alois Alzheimer first spotted these really strange changes way back in the early 20th century, researchers have been absolutely laser-focused on these two features. Understanding them has always been seen as the key to finally cracking this case.
All right, let's get a closer look at our two main suspects. On one hand, you have the amyloid plaques. These are basically clumps of a protein called beta-amyloid that build up in the spaces between neurons. Then you've got the neurofibrillary tangles. These are made of a different protein called tau, and they accumulate inside the neurons. Outside versus inside, that distinction is absolutely crucial.
For decades, the entire investigation pointed squarely at one of these clues as the main villain. So let's look at the case against prime suspect number 1, amyloid.
The leading theory for a very long time was known as the amyloid cascade hypothesis, and it was actually pretty simple and elegant. It basically argued that the buildup of this sticky beta-amyloid protein was the very first domino to fall. According to this idea, these plaques are what trigger everything else: the tangles, the death of neurons, and ultimately dementia.
So where does this suspect, this beta-amyloid, even come from? Well, its origin story starts with a much larger protein called APP. Now, APP just sits there on the surface of our neurons. A good way to think about it is to imagine APP as a long strip of paper. And the cell has these two different kinds of enzymes that act like paper cutters, and they can snip that paper in different ways.
So those two different paper cutters lead to two totally different outcomes. On one side, you have the clean cut. That's the good pathway. It produces a harmless, maybe even helpful little protein fragment. But then, there's the other pathway. It uses a different enzyme to make a different kind of cut, and that one produces the nasty, sticky, toxic beta-amyloid that clumps together. It's this bad pathway that's right at the heart of the whole amyloid hypothesis.
But you know, like any good mystery, the case just wasn't that simple. As the investigators gathered more and more evidence, the prime suspect's role, well, it started to look a lot more complicated, and an unexpected accomplice started to emerge from the shadows.
Okay, so here's the plot twist that basically stumped the entire field for years. Scientists found that some people had brains that were absolutely full of amyloid plaques, but they showed very few cognitive symptoms. The amount of plaque just didn't consistently line up with how severe the dementia was, and that was a huge hole in the theory. I mean, if amyloid was the sole killer, how could that possibly be?
This big inconsistency is what brought our second suspect, tau, right into the spotlight. Now, normally, tau plays a heroic role in the cell. It's kind of like the railroad ties for a neuron's internal railway system, stabilizing the tracks that move nutrients and all the important stuff around. But in Alzheimer's, tau gets chemically changed. It abandons its job and it collapses into these toxic tangles. And when that happens, the cell's entire transport network just breaks down from the inside out.
And this, right here, is the clincher. Research now shows pretty clearly that the number and location of tau tangles, not the amyloid plaques, are much better predictors of a patient's actual cognitive symptoms. It's like amyloid might be the one to start the fire, but a lot of people now think it's tau that really burns the house down.
So it's not just amyloid and tau working alone. The investigation has revealed this whole network of accomplices and contributing factors that make this case just incredibly complex.
Let's start with the genetic evidence. The single biggest genetic risk factor for the most common form of Alzheimer's is a gene called APOE, specifically a version of it called epsilon 4.
Now, if you inherit just one copy of this gene, your risk can triple or even quadruple. If you inherit 2 copies, your risk could shoot up to 15 times higher. That is a seriously powerful accomplice.
But here's some really good news. Genetics isn't destiny. In a really hopeful twist, research now suggests that around 40% of dementia cases worldwide are linked to 12 risk factors that are modifiable. We're talking about things like managing your blood pressure, staying physically and socially active, even protecting your hearing. These are factors we can actually do something about.
And then you've got what you might call the inside job, neuroinflammation. The brain's own immune cells can switch from being protectors to being attackers, creating this chronic inflammation that just damages neurons. On top of that, a breakdown in the blood-brain barrier, which is kind of like the brain's high-security gate, can let harmful stuff in, adding fuel to that inflammatory fire and speeding up the damage.
For a very long time, this was essentially a cold case. The only way to be 100% sure someone had Alzheimer's was by examining their brain after they died. But now, the forensic science of Alzheimer's has taken a massive, massive leap forward.
This new era is really defined by a total game-changer of a toolkit called the ATN framework. A is for amyloid, T is for tau, and N stands for neurodegeneration. That's the actual damage and death of the brain cells. Using things like PET scans and incredibly advanced blood tests, doctors can now see each of these pathological footprints in living people. They can literally track the disease in real time.
And here's the part that is just absolutely mind-blowing. This ATN toolkit can spot the biological signs of Alzheimer's 15 to 20 years before a single symptom of memory loss even appears. I mean, think about that for a second. We're no longer just reacting to the damage after it's been done. We can now watch the disease silently unfolding.
So what this all means is that we've gone from only being able to see the aftermath of the crime to being able to watch the culprits in action decades before the real damage is done. And that, of course, raises the ultimate question. With this incredible new window into the brain, are we finally truly on the verge of cracking the case and solving the Alzheimer's enigma for good?